Hi, and welcome to the video talking about representing functions. Our learning objectives for this video are to define functions, to talk about function representation as words, tables, and graphs, and finally decide if a graph represents a function using the vertical line test. All right, let's start by defining a relation. So determining whether a relation represents a function or not. A relation is a correspondence between a first set and a second set. The first set is called the domain, and the second set is called the range. So the domain, this is the set of inputs. And the range, that is your set of outputs. Let's think about an example to talk about relations. Every key, oh, where did that go? Oh my goodness, I hit the wrong button there. Okay. Every key on the piano corresponds to a musical note. So you push the key on the piano and it makes a musical note. And the input of this function is going to be the keys. So the domain of this function is the set of all keys. And the range of this function is your musical notes. Let's look at an example that is a function. So for a relation to be a function, it means that each input value leads to only one output value. A really good example that I like to use for this is a vending machine. So let's think about what a vending machine is like. So here's our vending machine, and I am not a great artist, so we're just going to hang in there. And your vending machine has buttons on it, and the buttons correspond to the different drinks. So maybe we have Coke, maybe we have like 7-Up, is that still a thing? And maybe we have water, and maybe we have 2 for water. Functions, inputs are the buttons, so the domain is the buttons, and the range is the drinks that come out. So when we think about each possible input only has one output, what that means is if you push the button for Coke, you're going to get Coke. You're not going to push the button for Coke and get Coke sometimes and 7-Up. Sometimes people would not like that. So you have to be careful about thinking that every input leads to exactly one output. There's no possible way you can put one thing and get one thing out one time and something out at a different time. The trick is you could have a repeated input. Like, for example, if you look at these bottom 2 buttons, these both lead to water. That's okay. You know what you're going to get when you push the water button. It's water every single time. That still has each input leading to one output. Let's look at another example using set notation. So here is my relation in set notation. This might be new to some of you. The first value in the ordered pair is going to be the input. So my input is the first value in the ordered pair. And the second value in the ordered pair is the output. So this tells me if I put input of -2, I get output of 2. If I put input of -1, I get output of 2. So what is the domain? Well, we're actually going to write this out in a set using set notation. So my domain, and lots of times use a capital D for this, equals this set. And I'm just going to list the numbers in the domain, and those are going to be all my first values in my ordered pairs. So -2, -1, and 0. That's my domain. My range, I use capital R for, well, every value in the second part of the ordered pair is actually 2 each time. So here is my output is 2, my output is 2, my output is 2. So the range is just 2. Now the way set works are you don't have to list 2 3 times. If 2 is in the set, it's in the set. It's like a grocery bag. If you put it in there, it's in there. So the range is just the value 2. So every single input in this function goes to the value 2. All right, let's think about another example. This is a function written as a table. Let's make this a little bit, oops, I hit the wrong button. Make this just a little bit smaller. So in this function, we're going to be working on movies and villains. So we're going to decide if this following table represents a function or not, and if it doesn't, we're going to fix it. So let's think about what is the relationship here? Well, we have our movies, that's our input, and the output is the villain of the movie. So, for example, if we put in The Little Mermaid, the output is Ursula. If we put in 101 Dalmatians, the output is Cruella. So our domain is going to be equal to all of our movies. And we're going to list them. So we have Little Mermaid, 101 Dalmatians, Harry Potter, and again, we have Harry Potter. We already have that listed in our set, so we don't have to list it again. All right. And what is our range? Well, our range is all of our outputs. So we have Ursula, Cruella, Voldemort, and Dolores Umbridge. All right, so that's our domain and our range and our relation. Now let's ask ourselves, does this table represent a function? Well, remember, for it to be a function, every input has to have exactly one output. But Harry Potter goes both to Voldemort and to Dolores Umbridge. So in some movies, Harry Potter's villain is Voldemort, and in other movies it's Dolores Umbridge, and sometimes both in the same. But regardless, we have two outputs for one input, so that is not a function. So this part right here is what makes it not a function. Hang on, I didn't mean to draw that line there. So no, it's not a function. Because Harry Potter goes, the input Harry Potter has two outputs. All right, well, can we fix it to make it a function? Sure. We'll just make Harry Potter's different. Voldemort was the villain in a lot of Harry Potter movies, but let's just pick the first one. So Harry Potter 1. And Dolores Umbridge was the villain in Order of the Phoenix. Is that Harry Potter 5 or 6? I think it's 5. Boy, I should look that up before I did this. I think it's 5. Anyway, we'll make it 5. If it's not, you guys can send me a text and tell me how wrong I am. All right, going on. Let's decide if a table is a function. So what I'd like you guys to do now is I'd like you to pause the video right now, go through these three tables. The top rows are your domains, and the bottom rows are your ranges for each of the three functions. There's 3 examples. And I want you to decide which of these are functions and which of these aren't functions, and then come back and I'm going to go over the answers with you. So just pause the video and work on this on your own. All right, did you get that done? Great. Let's go ahead. So let's look at the first one. Is it a function? Well, 0 goes to 3, 1 goes to 5, -1 goes to 1. So there's no input that goes to 2 different outputs. So yes, this is a function. Let's look at the second one. -1 goes to 3, 1 goes to 5, -1 goes to 1. Uh-oh, -1 goes to 3, but -1 also goes to 1. So not a function. And let's look at the last one. 0 goes to 0, 1 goes to 0, -1 goes to 0. Yes, still a function. It all goes to the same output, but each input has a specific output. 0 never goes to anything but 0, 1 never goes to anything but 0, -1 never goes to anything but 0. So yes, this is also a function. All right, now let's decide if we can. Let's learn how to decide if a graph represents a function. We have a cool test called the vertical line test. And the vertical line test says if you can draw a vertical line that touches the graph of a relation more than once, that graph does not represent a function. So let's look at our examples here. The first one is a function. Any vertical line I draw is going to only touch this graph once. There's no way I can draw a vertical line and have it touch the graph more than once. But this second example here, this like sideways parabola, isn't a function. And why isn't it a function? Well, because if we think about the input and output rule, let's look at this input right here. What looks to be about like at 3, right? X equal to 3. Well, at x equal to 3, we have a positive output sometimes. So this is about, oh, I don't even know what that is, like positive 2.8 about. But we also have a negative output sometimes, negative 2.8. And we don't know which one to choose. That makes it not a function, so not a function. And finally, let's look at our, well, it's not exactly a circle. It looks more like an ellipse. It's also not a function. For a lot of points, there's a lot of points where you can draw vertical lines and it hits the graph twice. And again, if we just look at this specific value of this blue line I just draw, x here is about -2, and y up here is 1, 2, 3. So we could get +3 sometimes, and we can get -3 sometimes. So not a function. So remember, the vertical line test is just a handy way to look at graphs and decide if they're functions or not. All right, that's it for this video.